Hello there and welcome. Welcome to the world of machine learning, where we program machines to think and make decisions just like humans. Have you ever wondered how Google seems to read your mind when you search? You type just one word and boom, it knows exactly what you're looking for. Or how YouTube seems to know exactly the video that you want to watch next. Yes, that's supervised machine learning in action, helping machines make predictions and decisions just like us humans. In this tutorial, we are going to take you from zero to machine learning hero. I'm going to provide you a step-by-step guide through each model. Together, we will train machines like professionals. And guess what? We are doing it without any boring lectures or complicated jargon. I am going to simplify everything and go straight to practical applications. We are going to work through real-world datasets and dive into hands-on projects using some of the most powerful machine learning models out there. Yes, here's what's coming up. We are going to do linear regression, logistic regression, support vector machines, decision trees, random forest, k-nearest neighbors, gradient boosting, and neural networks. Whether you're just starting out or brushing up your skills, this masterclass is everything you need. We are going to keep it simple, practical, and fun. No endless theory here. We are all about hands-on real-world stuff. By the end of this video, you will not only understand these models, but you also know when to use them and how to train them and how to make them work for you in every situation that you have found yourself in. Let's train these models and have fun together. Welcome to the world of machine learning. Hello friends, welcome to this fascinating world of machine learning. Right now, I'm just going to do a quick introduction of machine learning and talk about the popular models that are out there. Machine learning, at its core, is a branch of artificial intelligence. It is all about getting computers to learn from data and to improve over time without us humans explicitly programming the computer to perform each task or to perform the task at hand. Just like you and me, we learn from experiences, machines can learn from data and make better decisions as they process more information. Think of machine learning as your self driving cars, your Teslas. Think of machine learning as Siri and Alexa. Anything, just like your YouTube recommendations, basically that is machine learning at work. So, how does machines learn actually? Machines Machine learning models learn by being trained on large datasets. Throughout this tutorial, I am going to share with you datasets and we are going to train our models on those datasets. And then from those models, our machine is going to make decisions and we'll then feed those models with the new datasets and we'll see how our models will decide and then we'll verify those results to make sure that they are correct or not. So data is like the fuel that powers these models. Any model in machine learning is based upon data. That's why they say data is the new oil these days. So by processing this data, the model identifies patterns, trends, and any connection in the data, then apply to make predictions or decisions based on those trends and patterns. For example, a model might learn to predict house prices based on past sales data and then recommend the price of a house that you are going to sell. So actually, throughout this project, I have one project that would predict house prices. Machine learning is divided into three main types: supervised, unsupervised, and reinforced. So for supervised learning models, the popular models are linear regression, logistic regression, support vector machines, decision trees, random forests, KNNs, GBMs, neural networks, and polynomial regressions. So this model, I am going to explain this model in detail. So this model is basically this tutorial is going to share all these 9 models that you see right here. But other models worth mentioning are unsupervised models, where we have k-means, hierarchical PCAs, we have DSNEs, autoencoders, GMMs, DB scans, naive Bayes. We also have semi-supervised learning models. you find that out there they are categorized differently, but basically they follow the general guidelines. So on semi-supervised learning models, we have self-training, label propagations, reinforcement, we have Q-learning, DQNs, and policy gradient methods. On ensemble models, we have begging, boosting, and stacking. And now on anomaly rejection models, we have isolation forests, SVMs, and local outlier vectors. Then we have these deep learning models that you might be familiar with. Now we talk of chat GPTs, we talk of convolutional neural networks, recurrent neural networks, and also long short-term memory LSTMs or transformers. Then we also have generative adversarial networks. This is basically deep learning. Is basically most for you to understand deep learning. Think of just ChatGPT. All right, so in this model, I am going to do supervised, in this tutorial, I am going to do supervised learning models. So sit back, relax. We are going to explain each and every model, basis on how we can apply this model. We are going to install the libraries, explain each and every library, and then explain the whole process of applying a model, training the model on the data set, then visualizing the results. So sit back, relax, and enjoy. All right, so now that we have defined all these categories of machine learning models, basically we said we got three broad ones: supervised, unsupervised, and reinforced. But I went further to split them out as up to 7 categories. But the three main ones are those three: supervised, unsupervised, and reinforced. Now, before we even attempt to solve any machine learning problem, there's a general workflow that we follow through when solving these problems. So the first one is we have to define the problem. You need to know what are you trying to solve. Is it a classification, regression, and clustering problem? This will help you come up with an effective solution if you know what your problem is. And also determine how success looks like. Identify how you evaluate your model performance, its accuracy, its precision. Do you need to recall it? Do you need to improve it? Do you need to continue working on it? Then step number 2 is to collect the data. In our tutorial, we are going to create lots of data on our own, so that you have a hands-on experience in creating data. But in a real world, you might need to use SQL. You might need to do web scraping. You might need to do use CSV files, Excel files, or PDF files. So you need to determine where your data is, where it is going to be stored, and how you're going to maintain it going forward. You need to process your data. Step number 3. In real world, data will have those missing values. You have got outliers and duplicates. So you must find a way to take care of that. You can use NumPy to do that. You can use pandas to do that. You need to change the data structure. You need to normalize the data. You need to do splitting of data. Any ETL process that you need to do before you start analyzing the data. So remember, in a real world, you don't find perfect data. You have to modify the data to clean it up a little bit for it to be able to be analyzed. Need to select your model. Now, this is where the magic happens, because choosing the right model will guarantee you better results. If you just take a model and apply it across all problems, you're not going to get the best results. So you need some understanding of maths and the problem at hand. Train your model, evaluate your model. Maybe you might need also to improve your model. Also, to deploy your model in the real world, you'll need to deploy it in production. And now we'll be having new data coming in, and the model predicting the outcomes based on what you have trained with it. Of course, like anything else, you need to document it and report on it. You also have to present your findings through reports, through dashboards such as Tableau, Power BI, or Click, or make some visual assets through Python or R. All right, so that's the general workflow that we're going to be taking. We are not going to do documentation and reporting, but basically all these steps, we are going to do them together so that you can have that hands-on you're going to have that hands-on experience on how we define how to solve a problem in a real world environment. So for now, we are going to start here with supervised learning models, and our first project will be a linear regression model. So let's go ahead and start our linear regression problem, and then we can come up with a model and solve it. All right, so now we are going hands-on. We are going to do an exercise on predicting house prices using linear regression model. All right, so first thing first, we need to import our our libraries. So I have pandas spd, numpy is snp, matplotlib, cbone. Then from scikit-learn, I need trend test split, linear regression, mean squared error, and r squared score. All right, so now that we have done that, go ahead and type this in if you're either using Jupyter Notebook or Python or any other IDE that you have. Let's go ahead and do that. All right, now we need to create our data set. Our data set is going to be small and easy so that we can get started. So we need two columns here. We need the square footage and the price of the house. All right. So I have square footage right here. 800 square foot, the price will be 15,900. They will be corresponding like this. So the idea here is after, let's say we have a house that have got 4,300 square foot. We want to see the price. If it's the house that was 7,000 square foot, we want to see what we want this model to predict. What will be the future? What is the price of this square foot house? All right. So I'm going to run it. So I'm printing head here. Here, just simply saying, give me first 5 rows. So same thing here. 850, we have 150,000. For a 1,150 square footage house, we have 300,000. All right. So now we have our data set. The next thing that we need to do is just to plot this data set. So that we can have a visual how this data, how the square footage relate to the prices. All right. So to plot, we need two things here. We need matplotlib and cbone. So the figure size 8 by 6. You can reduce it. You can make it 6 by 4 for it to be a little bit smaller. Then x-axis will be the size. Then the y-axis will be the price. Then I'm going to use this data frame, which is this data, and also I'm going to tie to it house versus house size versus house size. I'll just add here square footage, square feet. Versus price. Then I want to show that chart. Alrighty, perfect. So we just plotted our data, and then it shows the relationship between the square footage and our house prices. So it shows that the greater the square footage, the greater the price. All right, so that's a nice one there. Now let's prepare the data for training. So we have our x-axis, we have our y-axis. All right. So we have our x-axis, which is the square footage, then the price y axis here, which is our y-axis here, which is this price right here that we're using. All right. So now we need to split our data. We need to train our data, and we need to split our data first. So we're going to run this one. And let me just add a cell here. Now that we have trained our data with xtrain.x test and y test, is going to use this x and y. Then we're going to split it. X and Y test size, and also the random set. We want to make it at 42. All right, so now that we have done this, we need to train our model. Markdown and run it. I'm going to run it. All right. I want to run this one first and run this one. Perfect. Now we have trained our model as a linear regression model, and now we're going to start making predictions. So to make predictions, 1, 2, 3, 4, mark down and run it. So I'm using this code to just make a quick prediction here. And now that we have done predictions, we need to evaluate it. So you are beginning to see those steps one more time. So to when we're evaluating, we need to see the mean squared error. We need also, we need to know the mean squared error. We have 0.99, which is almost 100%. So we're good here. And let's go ahead and plot this one. So I'm going to mark it down and run it. And run one more time. Perfect. So our model, which is in red right here, I'm plotting it right here to see how it is going to fit. It's a little bit bigger here. And I'll run one more time. Yeah, this is better. So our model here, you see this red line? It shows how my model is fitting to the data set. Right now, it's fitting pretty good, so I'm cool with it. And what we need to do now is to add new house size. All right. So we have our data frame here. So we're going to add another square foot and see what will be the price that this model is going to predict. All right, let's do it. Let me minimize a little bit. Perfect. So now we're going to add new data. And on our new data, so we're going to do new size is equals to our data frame. So I'm going to add 5,000. Let me just do a ridiculous one, a 10,000 square foot. So then I need to, let me increase the size a little bit. Yeah, better. Predicted price is equals to model predict. So when I print, of course, the predicted price. So I'm going to use formatted string here. Predicted price for 10,000 square footage SQF. Looks perfect. One more time. Let me just browse through one more time. 10,000 square foot. Uh-huh. All right, let's run it and see. All right. So I've added 10,000, and using the model that we have created together, I'm able to see that the price for a 10,000 square footage is 1,520,000. All right. So we can also reduce this one. Actually, I can copy this one and paste it. And let's do a 5,000 one. So we had 4,000 here. We had 4,000. Let's try 5,000 and see 5,000, and we're now doing 5,000 here. So for 10,000, it's 1,552,000, $520,997. Let's do for a 5,000 one. So I'm going to run this cell. For a 5,000 square foot, we have 780. So I think it's doing good. And let's do something which is close again for a 4,200 square foot house. 4,200, and now we're doing 4,200. So now you begin to see that our 4,000 square foot is giving us 662, which is fairly close to this one. The first one right here, 4,620. This is 662. Yeah, so the model is working as expected. So basically, that's how you do it. And you can now save it in a system. So whenever you enter a new square footage house, you are able now to predict its value. So you can do this if you're having a product. You can do this if you're having any item that you're selling or any item that you are bringing in. You're evaluating it and make sure you want to see where the price range is. So that's linear regression for you. Let's move on to the next section of the tutorial where we pick another model. Hello, everyone. Welcome to this section where we talk about logistic regression. All right. So on a previous video or previous section, we did talk about linear regression, and this is a different one, logistic regression. Basically, logistic regression is a model that we use to for I would say for binary classification tests, where the goal is to predict the probability of a categorical dependent. We have got two possible outcomes, whether it falls into this grouping or not. So it's kind of like a Boolean true or false, either it falls into this grouping or not. We use it to do basic tasks such as, let's say, wanna maybe categorize emails as a spam or not. They're either a spam or they are not a spam. We're gonna also use it in our example. We're going to use a heart disease data set. So we're gonna use it to look at the data set, predict if the person has got a heart disease or not. So that's basically, it's all about probability when I'm using linear regression, whether this one is in this category or not. All right. So in this project, we are going to use the data set in GitHub. So I have a link here. I'll put the link in the description also. So there's this data set, UCI heart disease data set. So you go ahead, click that link and also download it. So when you download it, you go back to your home and upload it. So I've already uploaded it. So that's why, let me close this pop-up. That's why I have the hard disease file here. So we're going to use that file. All right, so let's quickly take a look at the file to see what it has. It have got all these rows all the way. I think I can see up to, just scroll down a little bit. Yeah, there are quite a lot, 3 or 4 rows. Perfect. And the columns are age, which is the age of the patient, the sex of the patient. 1 is for male, 0 is a female. CP is the chest pain type, type 1, 0, 1, 2, 3. Then we have this trust BPS, which is basically resting blood pressure, say, cholesterol level, serum cholesterol. FBS is the fasting blood pressure, rest ECG, resting electrocardiographic cardiac, oh my goodness, electrocardiographic results, maximum heart rate achieved, this one. Then exercise induced angina, this one. The old peak is the ST depression induced by exercise. Slope is the slope of the peak exercise ST segment. CA is the number of major vessels controlled by fluoroscopy. Uh, this one is thalassemia, and target is then target tells us if this person have got a heart disease or not. So let's say 1, it have got 1 and 0 here. I'm just scrolling all the way down. Yeah, 1s and 0s here. So this person have heart disease, this one is not. All right. So that's the data set that we're going to use, and we are going to take a look at it in Jupyter Notebook. And first thing first, we need to import our libraries. So we have our pandas. Pandas, we always use it to read and manipulate data. NumPy to handle arrays. Standard scalar, we're going to use it to standardize the features. Logistic regression is, of course, the model that we're going to use. Train test split is split the data into the training data and the testing data set. Accuracy score, confusion matrix and classification report, we're going to use it to evaluate the model to see if our model is performing as expected. We're going to put it as a percentage to say 100% is what we want the model to operate at. We might not achieve 100% in our project here because we have limited data set, but if our model can hit 100% or 0.99, it will be one of our best models. Anyway, we are going to use matplotlib, and also we are going to use Seaborn to do visualizations. All right, so now that we've explained that, let's go ahead and load the data set. Load dataset, perfect. So our data frame is equals to, we are going to use pandas pd.read, and our file is a hat .csv file. Perfect. So now all we need is to just print the head, df.head. Perfect. So I'm going to print it out and let's see what we get. All right, this says an error. PD is not defined. I should have run this one first, then run this one. Perfect. Yeah, there you go. Then I'll run this one. Perfect. So we got our data set now, age, sex, that all these columns and rows that we've seen here. Only that in here we are just printing the head, so 0 to 4, which is 5 rows of data only, and it has pushed it to a new line here. So this is for new line, same columns and rows. All right, so that's it. Let's look at if there's any missing values. Let's do this one. Is now the sum. I'll just check if there's any sum of only now values in there. So I'm gonna print it out. Oh, perfect. There is now any, you see the results, there's 0 now values on all the columns. Perfect. All right. So now we have looked at our data. If there was any now, would you have entered those nows? We can just infer data or take the row out completely. That's a topic on its own. And if you, yeah, that's a topic on its own. Let's not waste time. All right. So let's go ahead now and prepare features and target. So let's do it this way. Want to prepare features and target. All right. So here, what we need to do is to split the data into features, which is the X, then the target variable into a Y. the target variable is whether the person has heart disease or not. So 1 is someone who put the heart disease, which is a yes. 0 right here, 0 target. 1 is someone with heart disease, and if it's a 0, the person has no heart disease. So if there is a 0 right here, perfect. So let's go ahead and do that. So to do that, you want to define your x and y. Let me do it this way. Define your x and y. All right. So our x here is equals to the data frame that we have. We're going to drop it. Then we're going to use that target column. Perfect. Axis equals to 1. So we're dropping, so we want to feature all columns except the target feature. Then our y is equals to then target. That's the target column that you want, target. Perfect. Actually, I need to repeat it because it's a string. Looks good. Let's see. Quick check one more time. Looks good. Let's run it. Perfect. Right. Now we have dropped our target. All we need to do is to do what we call feature scaling. So to do feature scaling, now you might know that logistic regression performs better when the features are scaled. So we will standardize them using the standard scaler. So we do our scaler that we imported already is equals to standard scalar, then our x scaled, x underscore scaled is equals to, use the scalar one. I want to transform our x. Let me look at it one more time. Scalar, standard scalar. So we're going to run it out. Perfect. So now the standardizer, standard scaler rather, scales the data so that each feature has a mean of 0 and a standard deviation of 1. For your standard deviation, what it does basically, it's your high school maths, so we're not going to go into that. But this helps you to improve the performance of the model entirely. So the x scaled is a variable that I've created that will contain the scaled features. Okay, so let's do training, test, and split. So now we will split the data set into the training and the testing sets. I would want to use probably like 75% of, let's go with 75% of the data for training and 25% for testing. So let's go ahead and do that. Training and testing. And we said we're going to do a 20% and say 25% and 75. All right. So we're gonna do our x train x test underscore I underscore test. Then we're going to do y train y underscore test. So is equals to train test train underscore test underscore split. We need to use that x scaled like this. Then y, then test size, we said it's going to be 0.25 or 25%. Then random. All right, so our random state here, I'll just keep it at 42. Perfect. So this is what we're going to work with, and we're going to run it here. Random random state, which I set it on 42, it ensures that the the splitted data is reproducible. And we set it on 25%, means that we're going to use that 25% of the data to test the results and train it on the 75% of data. Now, the larger your data set, the better. We have about 304 data rows of data. It's not that much, but if you have millions of rows of data, your model will be performing better. All right. So let's train now the logistic regression model. So to train the model is so easy. All what we do is to do model is equals to logistic regression max iterate 1000. Then wanna fit it, start model.fit xtrain, then ytrain. That's all we need to do. So let me take a look at it to see model. Perfect. So I'm going to run this one. Perfect. So this logistic regression, which I maxed it on 100, on 1000, it creates an instance of the logistic regression model. We set it to 100 to allow it to allow the model to run more iterations in case it needs to do what we call convergence. Then that fit trains the model using the training data. Basically, we're just training the model in simple terms. So what we need to do now is to model prediction and evaluation. All right. So want to make predictions on the test set, and also want to evaluate the model. So here's the trick here. So y.pred is equals to model.predict x-test. Then now we need to evaluate the model. Perfect. So to evaluate the model, we use these two accuracy score, confusion matrix, and classification report. So all we need to do is just to print it out. Actually, I can do it this way. Accuracy score. Then we want to do the accuracy underscore score y test, y underscore test, y underscore predicted results. Same thing for the confusion matrix. So we just want to print it out. Then we do confusion matrix. So confusion matrix. Same thing, we need y test and y pred. So I'm just going to copy these ones, copy and drop it in the brackets here. Same thing again for your classification report. Perfecto. So classification underscore report. Same thing, we need y test and y pred. So let me quickly take a look and go line by line. Yeah, there you go. So we are working with this. So the model predict makes the prediction of the test data, which I've explained, and also the accuracy score calculate the accuracy of the model by comparing the predicted values, which is y pred, with the true values, which is y test. And also the confusion matrix provides the confusion matrix, or the number which shows the number of true positives or true negatives or false positives or false negatives. It gives The classification report gives you a detailed classification report with precision recall or F1 for each class. So we're going to kind of run this one. We'll see the results. So our accuracy score is 0.881, which is basically 88%, which is not bad, it's great, but it's doable because of the size of our data set. And we just work with what we have, 80%. And now our precision, our accuracy is 88. So we're good. Weighted average 0.88. I'm cool with the results because of the data set. And now what we want to do is to visualize the curve. Visualize. So all I need to do is to, let me save time here. All right. So what we're doing here is we want to generate a range of values for the edge feature. Secondly, we want to match the scaling of the training data. Also, we want to predict want to return the probability of each class. We select the second column and it presents the probability of the positive class. Then, of course, we want to upload the regression curve. So we're going to run it. Alrighty, let's see what is working on here. All right, so the standard scale is expecting 13 results, but I had inputted one feature. So I've corrected my code here to make sure that I had 13 and run it. So I'm gonna run it one more time. Alrighty, okay, perfect. So this is our logistic regression curve. It shows that the probability of heart disease and also the age of the patient. And let's go ahead, and now what we want to do is, a model is fine, but all we need to do is to test the new data. So what we are going to do is to add new data, new data, then we're gonna test that data. So what we need to do is to edit some hypothetical data. The only trick here is that our data has to match the rows and columns as we have in the initial data frame. All right, so add new data. And what I've done a new data already. So what I'm going to do is just to copy it right here. Our new data. Perfect. And all we need now is to create a data frame for the new row with the same columns as the training data, and also scale the new data using this same scalar used in the training set, and also make predictions for the new data, and also maybe just do the output of the data. Alrighty. So all I need is to, all right. So our data set right here, so age is 45. Can I put it side by side? Actually, I can drag it somewhere here. Let's see. Oh my goodness. Let me pull it back one more time. There you go. It's coming up. Oh my God, it just crashed. Let's see if I can. We are at the end of this. We've already imported the data set, and now all we needed to do was to explain the results. But all the results that I did was just to show how the model was. Oh my goodness. Let me give it time. Perfect. There you go. All right. So what we did here, before it crashes on me one more time. Perfect. So we added the new data set, and what we did is to now see how the model is predicting the new results. So when I ran this one, it predicted. So I asked the new data using this data set if the person have got a heart disease or not. So it have determined that this person have got a heart disease. So that's basically what you do in logistic regression. We categorize data into it falls in this category or not. So now imagine if it's a hospital, when they get all, like they do they record all the patient that comes in, and they just punch in through the model. The model can predict this person have got are disease or not with 88% accuracy. It will help them find the problem further and also find a better diagnosis for the patient. So that's basically logistic regression for you, and see you on the other side. Hello friends. All right, welcome to this section of the tutorial where we talk about support vector machines. And in this tutorial, we're going to discuss this SVC, which is an implementation of SVMs. But let's take a step back and give the theory part of it. All right, support vector machines are basically machine learning algorithms that are used to classify data. It identifies a boundary or a hyper. We call it as a hyperplane, a boundary to classify data. Now, SVC is basically an implementation of SVMs. We use SVCs or SVMs to do like medical diagnosis, to classify our customers, our donors, to classify any data point that you might think of. In this example, we're going to use the iris dataset, which is a dataset of flowers. I've included a link here to the GitHub. So link here. And if you go to the GitHub, we have got this data point with 150 rows of data. If you scroll all the way down right here, see it's got 150 rows of data. And they've got three types of flowers: Setosa, Veriscala, and Virginica right here. So we're gonna look at these data points to see where does the Setosa flower ends, which are the boundaries for Setosa, boundaries for Virginica, and the Vesicola. All right. So that's basically the data set that we have, and this is the link to the GitHub. But you don't need to go to you don't need to go to the GitHub, but we can load the data set straight into our Jupyter notebook. So for starters, we need to load our libraries. Load my libraries. I'm going to run it. And we're going to use pandas and numpys for data manipulation. Then we're going to use scikit-learn dataset to implode that iris dataset. We're going also to use train test split, which helps to split the data into training and testing sets, and SVC, which is our support vector classifier, which is the core for this model. And also we want to evaluate our model to see how it is performing, and also matplotlib and seaborn, we are going to use it for visualization. Now, since we are using scikit-learn for our dataset, to load this dataset is easy. What you're going to do is to load dataset. What you're going to do is just iris dataset, load iris dataset, because it's provided by scikit-learn. So that's all you need to do to load the dataset. Now, so the dataset I've shown you a dataset already, what it looks like. So I'm not going to explain further than that. And now what we need to do is to convert our to data frame for visualization. So we're gonna convert to data frame for viz. All right, so I've printed the head here, which just shows you the data frame that we have. And also now what I've done here is to convert now the series, the species of the flowers into 0, 1, 2, 3, 0 for Versicolor, Setosa, and Virginica. Alrighty, let's go ahead and visualize this data. So we are going to use seaborn right here. And from seaborn, we're going to use pair plot. Basically, what I need to do is to just visualize those data points against each other. Then we are going to use species. Then I want to just show it. And run it. Perfect. All right. So we can see now those three species that we have is beginning to kind of give boundaries to the data points just to uh, it's visualizing those three flowers on sepal length, sepal width, and we can see those scatter plot kind of showing the boundaries which these data points belong. All right. So now we want to test and train, test, and split. I'm going to run it. So I've trained it on 30%, and the test size, the data that I'm going to use is 30% of the data. The more data you train on, the better your results are. And now what we need to do is to train the SV model. SVC model. And run it. Perfect. Now we want to make predictions and evaluate. We're having a 1.0 accuracy, precision 1.0, which is perfect. All right, so what we need to do here is to start plotting the decision boundary. And also we want to go ahead and plot that boundary. Perfect. All right, yes. So we begin to see that our data set is kind of grouped into three boundaries like these ones. This will be for setosa, veriscala, and virginica based on sepal length and sepal width. Now, this is perfect, and all we need now is to maybe come up with a new set of data. And from this new set of data, we would need to see how this data point will. We have created a model, so we need a new data set. We want to see how the model perform on the new data set. So I'm going to go ahead and create a data set and see how the model performs. So I went ahead and created this new data set, and now let's explain quickly and see how it performs when we come up with new data. All right. So right here, I've added a new data set, a sample length of 5.1 and 3.5, and we want to see how it is going to be plotted. So now I want to making predictions of the new data, and also now I'm loading it and also plotting the new data to see how it will fall on. So I'm going to run it, and the new data set is plotted under setosa. So basically, we load our data, we train our data, and whenever we have new data, the model will automatically decide which zone or category this data set falls into. That's basically your SV model. Cheers and bye for now. Hello everyone. In this section of the tutorial, we are going to do a project on decision trees. Now, decision tree is just a machine learning model that works like a flowchart to make decisions or predictions. It breaks down the problem by asking a series of questions, whether each question helps split the data into smaller groups. So it starts from the root, goes to the branches, then split it in continuous all the way out to the leaves, basically like a tree. So I'll eventually at the end, I will show you, I'll visualize the decision tree, but as for the sake of this tutorial, I'm going to show you how a decision tree looks like. So it starts from the root, branches, then all the way to the leaves. So basically, a decision tree looks like this one. And we are going to perform a decision tree like this. All right. So let's go ahead, jump into Jupyter Notebook and get started. So to get started, we want to use the wine UCI wine quality dataset. It's one of the famous datasets out there for machine learning. And I put a link, and I also add the link in the description so you can able to follow along. And also, when we are done, I am going to download this file, upload it in my GitHub repository, and I'll provide a link to my GitHub repository so that you can have the complete file. All right, so this is the data set. The data set have these columns. Fixed acidity is wine quality data set. Volatile acidity, citric acidity, residual sugar, chlorides, sulfur dioxide, total sulfur dioxide density, pH, sulfates, alcohol, and quality. So these are the corresponding numbers. Is a CSV file. So these are the corresponding values for these columns. All right, I'm going to go ahead into my Jupyter notebook and import it and get started. So first things first, we want to import critical libraries that I'm going to use in this project. I want to import pandas as PD. I want to import model selection, import again from scikit-learn. Actually, I want to import decision tree classifier. Again from sklearn. Confusion matrix display. Then I also want to import matplotlib. All right, let's see if I got everything that I need here. And let's see. So I've imported pandas and I've imported trend split, tree classifier, and this classification report, then accuracy score to measure the accuracy of the model and to display it. Okay, perfect. So I'm going to run it. All right. So now the second step that we need to do is to upload this data set. So what I'm going to do is to just use the URL. I can copy this one. And data is equals to pd.read. Actually, it's a CSV URL. It's separated by comma. Is it comma or semicolon? Yeah, it's semicolon. Right here. Perfect. Double check everything. All right. So let me print it out. Let me just do the info for now. And let's see what we got. Perfect, perfect. All right. So an info method just shows you what the data is. The columns that we have 11 columns. I showed you before the number of items, none now. Then the data type. These are all floats, and this is integer. Perfect. And also, let me just print out the describe. Perfect. So it tells me those are aggregates, mean is the standard deviation, mean, marks for each and every column that we have. Perfect. All right. Let me just check now the distribution of the quality range that we're going to use. Perfect. So we're going to do quality. We're using this column quality that value counts and perfecto. That's a distribution of the quality ratings. All right, perfect. Now, what we want to do is to start what I would call data pre-processing. So now, what we want to do is to drop our quality column. Then we train on the data. Then we can see if it's going to predict perfectly. Quality x is equals to 1. Perfect. Then our y is equals to data quality. Perfect. Then let's maybe for now kind of binarize. I'll use a lambda function here to binarize. We want to binarize. We want to determine what is quality. So if you don't know lambda function, there's a video that I've done for lambda functions that explains what lambda functions are and what they do. So if Q is greater than or equal to 6, L0, perfect. I would also want to check missing values again. So print data is now all right. We don't have anything that is now in our data. So perfect. Okay, perfect. So our x, what I've done here, we have x and y. We are going to use x, then y to test our results. All right, perfect. Now what we need to do is to split the data. And we are going to use train, test, and split. Perfect. So what we need to do here is we determine the number of items that we need. So 80% will go for training. We'll use 80% of the data for training. And of course, 20% will go for testing. Testing, perfect. And now we just have to code it out and 20%, our testers will be 20%, and we're going to use a random state 42 for reproducibility. Perfect. All right, let's go ahead and train the decision tree. And here, one thing we need to do is to initialize the model and train the model. So I'm going to say model, which is our model decision tree classifier. We specify the depth size. Now, if you do not specify the depth size, it will do, there's something that we call overlifting. So you do not want to overlift. Model.fit x underscore train, then y train. Let me run this. Perfecto. Now, let's go ahead and evaluate the model performance. X underscore test. Then we want to check also the accuracy. It's always good to check the accuracy and classification report. All right, so we need to print out our accuracy and accuracy score for Y and also for I would also want to print out the classification report. Classification report. Actually, I need it as it is for both Y test and Y pred. Perfect. Our accuracy 0.72, precision 6%. Alrighty, what did I have for 0.73? I'm good with the results. Let's move on. All right. Plot the metrics. So we want to plot the confusion matrix. So to plot the confusion matrix, we want to go back to our code right here and use this confusion matrix display. So I'm back again. Confusion matrix display estimate model our X test and C is equals to blues. And also want to plot the title. Our title is simple, just make it confusion matrix. And also gonna show it. Show looks good. I'm gonna run this perfect. Alrighty, so now, alrighty, so what I need to do now is to go ahead and visualize the decision tree. So to visualize the decision tree, we're gonna do and also I'm gonna specify the fixed size. So I would say 11 by 8 or 12 by 8. Yeah, it's fairly big. Then also feature names is equals to x dot columns class names. So we want bed. Want to classify if the one is bad, is good. And and also our title should be season 3 for wine quality and BOT.show. One more time. All right. Okay, fig size. Perfect. So right here, it should be fig size. And also, all right, plotted now. And we can begin to see our decision tree, how it's going on. Alrighty. Perfect. So let me see if I can be able, it will be large here, but let's see. And you can see those depth 1, 2, 3, 4, 5. All right. Now that we have plotted our decision tree and the confusion matrix, we can go ahead and do what we call hyperparameter tuning. So basically, hyperparameter tuning, you want your model to perform at its best. So hyper tuning. So to do hyperparameter tuning, you just want to fit your model. So you're going to use model.fit. And again, it depends on the depth. Our depth is 5. So we're going to do something like this. Model decision tree classifier. Max depth is equals to 10. Mean samples is equals to 10. Actually, let me do 5 here. Our random state, we'll keep it at 42. And also model.fit. Y underscore pred. What I intend to do at the end is to add new data. And after adding new data, I want to see how the model will perform when it is presented with the new data. Alrighty, let's see. Tuned accuracy of 0.72. It kept, let's see, 0.725. Okay. What if I increase the depth size to 10 here and to 10 here? Let's go ahead and do this. 0.71. All right. Let me keep it at 5 for now. All right. So our our model is 73% accurate. All right. So now that is our data. We have trained our model to predict if the one is good or bad. Perfect. So now we want to add a new set of data. So we're going to add the column and just one row, and we want to see how the model will classify that numbers that we put here as good or bad. All right. How it's going to classify that. So all we need to do is to create a new wine symbol. So new data goes to our partners now, data frame, and for our data frame, what we need to do is to, I'm going to just do this for now. All right, so now we just want to add rows and columns like we have right here. So I'm going just to copy this and come right here into my new data frame, paste it. Alrighty, it's gonna be a little bit of cleaning here, but let's quickly do that together. I'm gonna do it a little bit faster. Our pH. So we're gonna add new data, then we're gonna see how the model will perform, and we want it to predict the quality, so we don't need to include the quality. Perfecto. All right. So now what we need to do is just add random values. Let's say 7.2, and I will just copy this one, copy, and trying to save time here. All I need is a comma, 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 and a comma. Another comma. I'll manipulate those 7.2 just to come up with different numbers that are within the range, something that is closer to what we have there. Then I need a comma right here. Looks good. So what I need to do is to match the numbers. So we have got 0.7. I will just do on this one. I will do something like 0.6. And on this one, let me do 0.40 or 0.04, something like this. On this one, I'll do 2.0. And chlorides, I'll do 0.08. Free sulfur dioxide, I'm just trying to match what they have. 45, 0.9967, pH scale 3.30. Alrighty, sulfates, I'll go 0.65. I'm just doing random numbers here to see how the model will predict this. Just do a 7 here. Alrighty. So I've entered a new row of data, and the model will predict it. Prediction that predict my new data, and I want to print. So I can simply say predicted quality of the new wine is, then I'll add something like good if prediction is equals to 0. If it's 1, else I want it to be bad. So we want to see how the model predict. So just checking one more time. All right, perfect. So the predicted quality of the new one is good. Now our model is now performing as expected. And if I change the number here, let's say, let me just do some, I'm just adding random numbers here to see how the model predict this wine. Let me do a 5 here, a 5 here, a 4.9. So it excuse me, it's gonna use that the result of the model to see if this wine gonna be this is still good. Alrighty. So depending on what the model is predicting, they're still good. So imagine we're having a large data set. Let's say we have put 10 years of data, and now we train our model on the past 10 years of data, and now without even having wine testers, we can push it in machine learning and able to predict if the wine is good, is bad, without any other input from any wine testers or any other thing. So that's basically your decision trees. The video has been long, but that's how you do our decision trees. Thank you. See you on the next model. Hello everyone. In this section of the tutorial, we are going to do random forest, and I am going to use the UCI adult income dataset, and a link to the dataset is right here. I'm going to keep this link in the file, and also I'm going to upload it in my GitHub so that you can follow along. All right, so what is random forest? It is a machine learning model that is used for both classification and regression. um, think of it as a collection of many decision trees working together. I'll give a basic example. Let's say you have like 100 friends and you want to decide whether you're going to pack your jacket today or not. So your friends will look at multiple factors such as weather, such as clouds, past experience, the time of the year, and all the other factors that they might think of. And you ask those people to vote, and you go with the majority decision. That's basically how random forests work. So we are going to apply the same concept now using the actual data set. And at the end, we are going to upload or add new rows of data. And we are going to see how this model will predict. So let's go ahead and get started. All right, so from our data set here, the goal is to predict whether an individual $50K and more than $50K or less. All right, so that's the goal of this tutorial. All righty, and let's get started. Of course, what we need to do is we are going to import critical libraries to get started. And of course, I always want to manipulate my data using pandas. And also I want to import NumPy as NP, and I'm also going from scikit-learn. Actually, I will also want to use matplotlib, splt, then from scikit-learn.ensemble, I want to import random forest classifier. And also from sklearn model, sklearn dot model selection, I want to import train, test, and split. Also from sklearn dot metrics, import accuracy, score, confusion matrix, and I also want to do classification report. So, and I also want to from sklearn.impute, I want to import simple imputer, and from sklearn dot pre-processing, I want to import one hot encoder, label encoder, and also it's a lot here from from uh, from sk scikit-learn. I want to dot compose. I want to import column transformer from sklearn dot pipeline import pipeline. Then lastly, I want also, so it depends now. If you know what you want to do, you can go ahead and start to import. But sometimes you might come back again and upload these libraries before you get started. So there's no really a best way to do it. It depends on how you figure it out, how you want to um, to work it out. Data. So our data, we are going to say that we're gonna use CSV. So we're gonna throw this one into right here. So copy. I just gonna drop it in here. Perfect. So what we want here, we want to identify those columns. So actually, I can also do names is equals to. So right now I'm just gonna pull those names out, and I'm going to. So I want edge. I want weight class. I know this data set, so you might need to take a look at your data set and see what you want in a real world scenario. All right, weight class. Let's do, there's this column FNL, WGT, and also education. Imagine you using this model to predict the, let's say you are a bank, you have people that are applying for let's say any loan, whatever it is. Instead of relying on what they will say by the word of mouth, you can use the model to determine what salary they might be making, and this will save you a ton. And you can also make your business decisions more fact-based than opinion-based. We want sex. I also want capital gain. I also want capital loss. So it depends also on what factors you want to consider in this model. It's all up to you. And the best, I would say, the best that the best that you can have is to provide as much information to your model as possible, so that your model can be based on data, real data, than it's better to have a lot of data than not. All right. So now I've uploaded this data set and I want to have these columns. What I will need to do is to maybe just take a look and see if I have done it correctly. So data.head. So let's see what we got. Perfect. So these are just the columns that I have, and also just basic information here. All right. Perfect. So manager status, occupation, relationship, capital gains, capital loss, hours per week. All right, perfect. All right. So also, I would want to. It's always a good rule of thumb, unless you have cleaned your data and you know exactly what it is. Actually, by the time you start to build your model, you would have cleaned the data. I would say start cleaning your data first. But sometimes it's a cycle. You might need to say, okay, I've cleaned my data, but I need to check there's some more nows. I need to go back and clean it. So in this case now, I don't see any nows. It's an integer type. Perfect, perfect, perfect. All right. So we have printed our head and info. Now we want to select the relevant columns, or we would call them relevant features. So to do that, I'm going to just do this so that I can have it right here. All right. So to do that, what we need to do is use these features. So I'm going to copy this one and right here, and then I'll say features is equals to paste. Then I will just take the names out. Looks good. Now we want to, I want to take income out because I want my income to be target. So what I'll do is I will just say for now, target, just follow along. Do not get lost here. Income. So my X data equals to data is equals to features. Features. Then Y, the one that I want to predict. So Y is equals to data. Alrighty, then target. So take income out from here. Let me double check and see if everything goes as I want. Alrighty, age, working class, education. All right, I might not need this one. Education now, I don't really need it. I don't want to train it on education now. Marital status, yes, might need it. Occupation, yes. Relationship, yes. Race, sex, yes. Capital gain, capital loss, I don't think this is useful. Probably I'll just keep, yeah, let me go ahead and keep hours per week and native country. I don't necessarily need it. Looks good. So let's go ahead and run this. Perfect. So now we have our X, and now let's see if there's any missing values. Again, just double check everything before you proceed. So let's say X is now, and on a sum all the nows, and let's run and see. Perfect. We're good. All right. So sometimes you might need to fill missing values with the most frequent items. So we're gonna just do that. We're gonna use the impute. That's why I imported the imputer. So let's do simple imputer. So you have to specify the strategy. Our strategy will be just if there's any um, the most frequent one. Frequent, and also I want to do X is equals to PD data frame, and imputer dot fit transform your X, and also columns columns. Perfect. Let's take a look and see. Looks good. I'm gonna run it. And let's now encode categorical variables. I should be just adding encode categorical variables. Perfect. So we're going to use the encoder. Encoder is equals to 1 hat encoder. I want to ignore here. Ignore. And also x is equals to pd dot data frame. Transform x, and also let's do, yeah, to array. Looks good. And what we want to do is to double check and run it. Perfect. Now, after we do this, now we can go ahead and train, test, and split. So to train, test, and split, we have our xtrain, xtest, x. We just want to specify, do we need to train on 70, 80, 90, whatever it is that you want to train on. So let's go ahead and train it. X, train, x test, y train, y test is equals to train, test, and split. So we have our x, we have our y, we have our test size. You specify the size that you want. So I want to train it on, let me go with 70. So my test size will be 0.3, which is 30%. A random state, I'll keep it at 42. And also, let's see if I got it right here. So now what I want to do is to run this cell. Perfecto. And now that I want to go ahead and build the model pipeline. And to build the model pipeline, all I need is to specify model is equals to a random forest classifier. So estimators is equals to 100. A random state is equals to 42. Perfecto. Now, what I need to do is to, before I do that, let me run this cell. So I'm going to run the cell. And now let's feed the model. Actually train the model. Train the model. To train the model, just model.fit xtrain y train. Perfecto. And now that we've trained the model, let's make a predictions. And to make predictions, we use our y pred is equals to model predict xtest. Y pred equals to model predict xtest. Perfect. I'm gonna run it. All right. Now that we have trained our model, we've made predictions. Now we need to evaluate it to see what is the score. So to evaluate, evaluations. So we're going to use the accurate score, we're going to use the confusion matrix, and the classification report like we have been doing previously. So I'm going to print, let's do accuracy score. So for the accurate score, we want y test and also y pred. We're going to run it. We have got 82% or 0.82. Perfect. So we're going to do, this is evaluation number 1. Let's do, let me run it one more time. Perfect. Then evaluation 2. For the second one, we want to do the confusion matrix. So for the confusion matrix, we want y-test and also y-pred. And I'm going to run it. 6, 7, 6, 5, 12, 52. Looks good. Then let's go ahead and do the classification report. So classification report, our y undergoes test and y-pred. Accuracy 0.82, support, effort score 0.89, recall 0. Okay, perfect, good. All right, so now our model is working and our precision is 0.86. Now, all we need to do is add a new data set. Now, after we add a new data set, we're going to see how this model will predict on the based on the new data set that is added. So to add a new data set, add new data. So just say it depends on it can be a new CSV file. For now, I'm just using one row of data to do that, but it can be a new data set. So data frame, I want to close it, and within it, I want to open up like this and do, and also close it and just do something like this. Now, perfect. Now I just have to specify those variables. Age is equals to, let's say 45. I can do 2 rows of, yeah. Then of course my comma, work class, and those, remember, like I said previously, those these column names should match. Any mistake will not, it will not be able to add to that column. All right. So I had 2 here. So let's go with private. If you check here on work class, there's this self-employed, we have graduate, not in a family. So when I just match what we have here. All right. So we have got private and self-employed. Let's use that self-employed that we have seen. Self-employed, not income. Let's go ahead and do, actually, this was better for visualization. Let's do education, then we're gonna do those 2. So for education, I'll just go with bachelor's. I'm just adding new data sets right here. Bachelor's and also master's. Come on, let's go with another one, which is marital status. Then we're gonna go with 2. So we're gonna do never married, and also married. I'm just copying what I have, spouse here, and just changing a little bit. We're gonna do occupation. Then we're gonna do any occupation that you might think of. I'm thinking of tech support, and also let's do executive managerial. Relationship. So for relationship, we're gonna do not in family, and another one I'm gonna do husband Let's do res. I'm just going along with those features that we did, the variables that we trained our model on. So we're gonna do y and black, just for it to be consistent here. Then we're gonna do sex. Sex, we're gonna do male, female, and hours per week. We're gonna do 40 hours, and this one gonna be like 50 hours. Perfect. So let's double check to see if there's no errors. Looks good. So let's go ahead and run it. Now, what we want to do is to impute it and also to then print the new predictions to see how now we've added the data. We want to add this data to the data frame and see how the model will predict it. All right. So to do that, we have our new data. New data. We're just adding. Then new data goes to be the data frame. I want to use encoder to transform our new data, a new data to array. Perfect. Transform. Then of course we would need to print it out. So we have got those two people. So now all we need to do is to print the predictions. New predictions. So if I print this one, we're gonna see how person number one and person number two will be categorized. So actually, let me do it this way. And we're gonna predict on this new data. So I'm gonna run it. So the first person, the model predicted that is making less than 50K. The second one is also making less than 50K. All right. So let's see if we do 100 and see how our model will do. Or let's make it ridiculous and see. The model is still predicting that based on these vectors and all the data that we have, this person is still making. So to now, the last step that I want to do is to visualize. Visualize. So to visualize, it's what we want to do is to go ahead and do. Let's determine the figure size, fixed size, and our fixed size is gonna be. Let's go. I'll go with 30. This will be large, but let me go with 25 and maybe 10. Then we're gonna do plot tree. We're gonna do and just 0 here. Also feature names is equals to encoder. Actually get feature names out, and also want it to be filled, and you determine the font size. I might go with a 7 here. Then our title, random forest decision tree. Visualization. And lastly, I just want to show it up. So it's quite a large lift. Let's see if I can. It's quite a large lift. It might take time, but let's see if I can quickly run it and show it. Or while this is running, I am going to pause and show it when it's done. Alrighty. All right. It took time to run, but here's our final decision tree. And you can specify the size that you want to do here. But basically, this is our decision tree. And I can maximize it, but you'll be way down deep into the tree. All right. So that's basically how we do it. And thank you for watching. See you on the next model. Hello everyone, welcome to this section of the tutorial where we do KNN model. Alright, so in this tutorial we are going to use the scikit-learn diabetes dataset, and the goal is to predict diabetes progression based on various health measurements. Alrighty, but before we get started here, let's go ahead and explain what K nearest neighbors is. Yes, it is an algorithm that is non-parametric classifier, which uses the proximity to make classification or predictions about the grouping of any individual data point. So what it happens is, let's suppose that we have data points that are plotted on a graph, and now we want to classify a new data point. So what KNN model does is it looks at the K closest points or neighbors around that point, then it measures the distance between the new point and the existing points, usually using the Euclidean distance. There are other ways to calculate it. The model that I'm using right now is going to use the Euclidean distance, but there are other ways to calculate the distance. For example, some uses the Manhattan distance, some uses the Hamming distance, some use the Minkowski distance. So there are kind of variations in how they calculate the distance, but basically the most popular one is the Euclidean distance. All right. So let's say, for example, if let's say we let's say all the nearest points, let's say out of 5 points, the nearest points are 3, and the point to a certain category, the new point will classify to that category. Or maybe let me give you a simple example. So K means the neighbors that are to consider around the data point. So imagine if you're an individual, you move to a new neighborhood and you want to make friends. You meet like 5 people, and ask what they like. And 3 of them say they like soccer, and 2 they like basketball. So it means you are likely going to join the soccer group. That's basically KNN in action. It looks at the neighbors around you and classify you accordingly. I think that's the best, simplest way to explain it. K simply means the number of neighbors to consider. All right. So we are going to use the scikit-learn dataset. So I have already imported it right here. And we have also taken the accurate score, classifier, report, mean squared error. Let's go ahead now and just load our dataset and get started. So what we want, I will need to run this one. What we want to do now is to load the dataset. So to load the dataset, what we need to do, excuse me. All right, to load the dataset, what we need to do is to I need underscore here. The data is equals to, I need to change it to pandas so that I can work with pandas. Diabetes, data, columns, is equals to the beauties dot feature names. The target. Perfect. So now that we load our data, I'm gonna run it. Let's take a look at this data and see how it looks like. Remember, you can look at it on your own. So I just want to first show the first 5 rows. So we would edge 6 BMI BP, S1, S2, S3, up to the target. Okay, perfect. Let's go ahead and just visualize this data set and see what we got. Visualize the data set. Perfect. So to visualize the data, we're just going to do figure. We want to fig size. You specify the figure size. I'll go 10 and the 6 here. How do I want to figure is I want the scatter plot. See map. Oh my goodness. BOT X label. I would want to go with just edge here. BOT Y label. Your Y axis. I'll go with X and POT title. I want it to be diabetes data V's. Let's just do so. First 2 features. Then I just want to show it. Alrighty. Double check everything. Okay, scatter plot in a double T. Alrighty. Let's correct this one right here. Okay. So that was the issue. There you go. So now that I have plotted agent sets here. You can go ahead and plot different features here. But with this one example, let's just go with agent sets. And now that we have plotted, let's go ahead and split our data. So we just take the same way that we did since the first models. So I want to use all the items except all the columns except the target. So it's one of the ways to do it. Day two. And now that we have separated the target, I'll first maybe run this one and. And now we do train. test and display. All right, so X train, X test, then Y train, Y test is equals to train test split X. Our test size, I wanna keep it at 70, which is 3% the test run, and random state on 42 as usual. Alrighty. Now that we have done this, let's go ahead and train the KN model. Alrighty. So to train the KN model, like what you did earlier, using different models, our model is K neighbors classifier our neighbors is equals to 5 KNN. Wanna fit it with X train and also Y train. Now, you can train it with different. So right here, I've used 5. You can see 6. It's all up to you. I used 5 neighbors here. All right, so let me initialize it. Perfect. Now that I've initialized it, let us do the predictions. Y pred is equals to knn dot predict x test. Then I wanted to print the mean squared error. I can do it on a new line maybe. Squared error, and also the print mean error one Y test and Y pred. Our mean squared error 723.067. Perfect. Now, now that we have done this, all we need to do is to add a new data set. So again, new data. Want to see how is this going to perform. So to do our new data is equals to pd the data frame let me go ahead, boom, boom, and go ahead and do my first data set. Then the second one. And now all I need is columns is equals to diabetes dot feature names. Looks good. Then I want you to predict the new data and also print it out. Now you can create as many data as you want here. I just did two just for consistency. And let's run it. All right, it's 1520 and 2220. 150 for data point one, which is this one. It says this person, the ability progression is 150, and this one is 220 because of the new data set that we have done. So, in a nutshell, that's how we have done our KKA model. So, you see others at 150, 179. So, based on all these factors, but now we have added new measurements and we have determined that this person is on target 150 and 220. Perfect. So, what I'm going to do is I'm going to save this file, and I am also going to download it up and also share it in my GitHub repository so that you can go ahead and pick it up and edit this file and do more with it that you feel like. Thank you for watching. See you on the next model. Hello everyone, welcome to this section of the tutorial where we do GBMs, gradient boosting machines. This is one of my favorites, so we're gonna just stay tuned and let's walk through the project. So we are going to use the Titanic dataset, and the goal there is to predict the survival of it on the Titanic using the GBM machine model. And before we get to the libraries and everything, let's explain what is gradient boosting machine and how does the model operate. Is of when you have a large data set, I would say first thing that you must think of if you are using a supervised learning machine, think of GBMs because it is very good in handling large amounts of data. You can also solve both the regression and classification problems. So what GBM does, it builds many models, which are basically decision trees, step by step. Each new tree tries to kind of to fix the mistakes made by the previous trees. So the model improves as more trees are added. So other models, GBM, instead of making one big model, GBM makes lots of small ones and combines them to get better results. Think of it as a sculptor. What that it does is chips one chip at a time, one tree at a time. Then at the end, it comes up with a very, very beautiful result. GBMs are used if you want to get high accuracy, flexibility, and also to handle missing data. But the downsides are it is very slow to train because it builds those many trees, and also if not tuned well, GBM will do a lot of overlifting. So you have to do your performance tuning before you trust your results. That being said, let's go quickly into my Jupyter notebook and let's get started. So we want to predict the survival of someone if he, depending on the factors or the features that we have. Alrighty. So let's go ahead and load the dataset. So to load the dataset, we just have to say data is equals to pd dot, it's a CSV file, read.csv, and push it everything here into copy into the brackets, and after that all we want to do is to explore the data. So print data.head. Let's take a look and see what we have here. All right, let's see. Hey, crazy. Let's run one more time. Now I want to print again data.head. Perfect. All right, so these are the first 5 columns. So we've got passenger ID, survived, PC class. We have the name of the people who were on board. We have sex, age, CIB, BSP, we have purchased ticket, fare, cabin, embarked. All right, perfect. All right, so now let's quickly do the info. Oh my goodness, what am I doing? Data.info. Perfect, perfect, perfect. So we have 11 columns. And now, now. Mm-hmm, mm-hmm. All right. Let's do data.describe. So we have our mean, our standard deviation, max. Alrighty. Count, count, count. So looks like we'll take a look in detail. Looks like on edge we might have some nulls in there, but we'll come to that later. All right. All right. So now let's see if we can visualize any missing data. So to do that, all we need to do is to use Seaborn. So data is now and there's nothing, then CMap. Missing values HMap. And also, actually, all I need is to show here. Okay. Yes. So we can see that our edge have put missing values and also cabin have missing values. So we might need to drop it or fill it. So let's see what's the best. Like I said, data cleaning is part and parcel of this career path. And sometimes you clean your data depending on the results. You need it's a circular in motion. You look at the results, go back, clean the data back and forth. So it's part and parcel of this career path. Alrighty. So what I would want to do here, I would want to fill in. I would want to fill in the the missing values for age with the median and embarked with the mode. You choose what you want depending on the goal. I choose median mode here. So we're gonna do edge and the data. So let's go ahead and continue to edge. Now, these methods, I have a video which explains pandas in detail. So go ahead, take a look at that video and see what you can, or just go on documentation and and have a walkthrough on 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 pandas methods so that you can know what to use, when to use. With data, but I wanted to fill with the mod. And right here, perfect. So we're gonna run this one, and let's drop. You see cabin right here. You've got just too much missing values. So let's do another data cleaning here. So I want to use the drop method. And what we have is cabin. Alrighty. Actually, I don't need patch and ticket. Okay, I don't need ticket also. Let me take ticket out. Doesn't really help in this um, analysis. Axis is equals to 1. Let's see one more time. So some of the columns that you don't need to keep it, because it will take time to process. It will cost you more. Let's say we have millions and millions of rows of data, so you don't want to overlay on things that is not useful. So I want to do some conversions here. Conversions. So there. Mm-hmm. So I want male and female. So if you notice here, we had female, female, female. So I want to have a numerical number. We cannot really process strings here. So I'm changing male to 0, female to 1. You can change it the way you want it. I just did 0 and 1. Alrighty. Data is goes to PD get column. Mm-hmm. Alrighty. All I need is to run this and see. All right, perfect. And now features and target. So our X and our Y. And notice I'm capitalizing X and I'm also lowercasing Y. That's conversion and that's what we do. All right, for X, what I need to do is to specify those features. So data. All right. So if PC class, P class, these are just columns that are in the dataset that I'm using. Age, CIBSP, then we do fair. Yeah, I'll keep fair, probably because of the fair that they paid, probably to influence the seed they said. So embarked S Perfect. For y, I want to see if they have survived or not. So we're going to do survived. Perfect. So let's run this and see what we got. Good. And let's go ahead, split the data. So to split the data, we've done this several times now. So X train, X train, X test. Then we have Y train, Y test is equals to train test split our X, which is X train, then Y, then test size. I still want to go with 80%, so my test size will be 0.2. Then random state, keep it on 42 as usual. Alrighty, let's run this and see if it goes through. No error. So we're gonna run this and perfect. Now, now our steps are now easier. Train the model. The good thing is we had been able to go through this together to see how each and every project is different. Gradient boosting classifier and I'll say 0.1 max state because they are all distant trees, so you have to specify. Otherwise, you come back again to the issue of overlifting. All right, model.fit. Let's quickly do it now. So our X train and Y train. Double check everything and okay. All right. Discard. This is not the file that is being affected. So I have discarded that one. It doesn't really affect our project at hand. All right. So we have initialized our model. Let's go ahead, train the model, initialize it and everything. So let's go ahead and evaluate the model. So to evaluate the model, like I said earlier, model predict X test. I'm moving a little bit fast now. Accuracy is equals to accuracy score Y test Y red, and let's print print accuracy and check what we got. Accuracy 0.8% or 80%. Let's also go ahead and print classification report. So print a report for Y test and Y test and Y classification report classification. Run it. Precision 0.8, accuracy 0.8, support record. All right. All righty. Let's do the confusion matrix. I'm going to use the heat map. I'll go with blues. And let's plot the heat map. Actually, let me do the title. Metrics and show. All right. Double check to make sure everything is looking as expected. Perfect. 010124 11. Perfect. All right. Let's just do a quick feature importance here. Want to see which feature is influences the results. So feature importance is equals to model dot feature importances plot dot figure, then specify the fixed size. Then also Seaborn, I want it to be a bar plot. You can, depending on what you want to, how you want to visualize it, you can visualize it differently than me. Perfect. Then I want the title. I just want to call it feature importances, and also just to show it out. Double check everything. And whilst I'm here, let me add some columns so that it can be on top of my screen, not on the bottom of my screen. All right. So I'm going to run this one. Perfect. Oh, good. So it shows that sex had more impact or importance compared to the age, fair. Yeah, like as expected. The class which the person was seated at had also an impact as expected. Perfect. So, like I said earlier, we need to tune our model. Alrighty. So, to tune our model, we need to do I'm moving a little bit faster here. I won't be explaining a lot just because I want my video to be a little bit shorter. But you follow along. But at this point, you should be able to understand what's going on here. 0.2. And let's do max step. 3, 4, and 5. And let's just close this. I can increase the font size here. Perfect. And run this. And now what we want to do is to continue with tuning. So to save time. And also I want to evaluate the best model. So to evaluate the best model, Fred best is equals to grid search. search best estimator predict. Now, as we move through these models, you can begin to see that there is no perfect model. There is nothing like a perfect model. You have to choose the best model that you think will work best for your use case. So there is no a magic model, magic test accuracy. It's all about finding the best model. Best accuracy. Why is it not? All right. Alrighty. So my improved accuracy is now 82%, 83%. Perfect. So now to test our model, test with new data set. I want to see if this person would have survived. So new data is equals to your appended data frame. Now, and also you begin to notice there would be other things that would affect the survivability of this person, of these people, other than just because of the data point that we have here. So again, machine learning models, they have their limitations. So use them with caution. Yes, they might give you somewhere closer, but things may turn out to be different. We have seen people who model things and eventually they'll find out that the real world is a little bit different than what they would have modeled. So use this knowledge with considering all other factors. So I'm just adding age here of those people. You can add whatever age SP. These variables, they are typically up to you. 0 and 1. For fair, I'll go with 7.25 and 71.28. Now, this dynamic data set, we have used it in many data science projects, especially in Tableau. So we have added a new data set. We want to see how our model will predict. So new predictions is equals to predict just for it to be predictions needed to all we are doing is printing predictions. All right. So it says this: if a person had all these attributes 3, 1, 25, 0, 0, 7.25, 0, and 1, they had a 0 chance of survival. But if they had a PC, class of Y, sex of female, age of 38, all these attributes, they would have survived. So that's basically how we do GBMs, and we have to use this one for 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 the Titanic data set. All right, so basically that's all. Let's move on to the next model. Hello everyone. In this section of the tutorial, which is the last section of the tutorial, we are going to discuss the feed-forward neural network, and we're going to use the MNIST dataset. The goal is to classify handwritten digits from the MNIST dataset. But what is feed-forward neural network? This is one of the simplest types of artificial neural network used in machine learning. Let me break it down to you. So imagine the network is a series of layers, actually for 3 layers. Data enters from one side and exits from the other side, moving in one direction. Hence, we term it feed forward. Here with those 3 layers: input layer, hidden layer, output layer. In the input layer, this is where data enter, whatever form of data that you have, it enters, is fed into the network. The hidden layer, this is where we compute our calculations and the model learns patterns. The output layer, this is where the final result or prediction is given, uh, like classifying an image or maybe predicting a number. So how does it learn? Initially, the network makes random guesses, but over time, it adjusts through the process called training. We are going to train our model together, where in the network compares its predictions to the correct answers and improves by adjusting its internal settings, which are called weights and biases. Um, it can be used in handwritten recognition. That's what you're going to do in this case, and also simple image classification, in fraud detection, in almost any other data that you might have. So, like I said, we are going to use MNIST dataset, and let's get started. To get started, what we need to do is to import critical data, critical um, libraries. So I've imported TensorFlow because our data comes from TensorFlow. I've also imported NumPy, Matplotlib, and scikit-learn metrics. Alrighty, now that we have imported our critical libraries, let's go ahead and load our data. So and remember, you can always use the dataset that you are comfortable with. There is no best data or what. It's all about whatever data you're comfortable with. So don't be stuck with my datasets, but just work with the dataset that that you are comfortable with. All right. So now I want to do is to um, do what you call normalization. I might want to use alrighty. So X train is equals to X train to 55.0 and 255.0, and X test is equals to X test 255.0. Just adding these cells so that I can be able to push it a little bit up. Perfect. Alrighty. So now that we have normalized, let's go ahead and flatten. or images. And now that let me run this one. Now that we flatten, all we need to do is to build using the input layer. All right, so you specify your inputs. Then also your X layer. And also you want to do and so let's run this, and what we want to do is to compile the model. So to compile the model, use model compiler. Perfecto. So after compilation, you always want to test the model. So to test the model, train the model rather. So to train the model, I will assign it to history, run it. One of okay, perfect. Let's see. Alrighty. All right. So could not interpret loss identifier sparse categorical. This is the issue. So that's why we got a value error. So categorical. This should be correct. And all I need is to run this. Run this. Perfect. So let's finish. Let's finish the results. I'm just waiting for it to complete the results. Accuracy 85.85.95.96.97. So it's going to take a while, but it's going to finish very soon. So while this is working on that one, so let's do all right for model evaluation. What we want to do, all right, 858598979898. Oh, perfect. All right. So now we want to evaluate our model. I'm going to evaluate it out. Our accuracy is 0.98. Alrighty, let's visualize it. Now to visualize the model, we are going to use the matplotlib. So I'm just going to run it. So this is our training accuracy and our validation accuracy. That's why we've got a 9.78. It's not 100% perfect, but it's close enough to get started. So let's do the predictions. Or list and I visualize the sample predictions. It's effectively predicting the numbers. This handwritten digits is it able to predict 1 is 1, 4 is 4, 9 is 9, 5 is 5. Perfect, 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 perfect. That's good. So it's being able to identify those handwritten digits. Let's evaluate using confusion matrix. All right. Alrighty. Double check everything and run it. or equal 0.99, 0.97, accuracy 0.98. I'm cool with it. Let's test our model with a new dataset. So this is a random data. That's where I'm using NumPy. Though this is not a hand-trained data, but we just want to test our model with it. So any actually let me push it up a little bit so that it can be easily viewed. And now that I've added random data, I want to visualize the best would have been to have handwritten data, but we have to work with what we have. Fixed size, I want to specify the fixed size. I'll just go with 10 and 5 and just do a for loop in here. For I in range, specify the range. Let me use 28. Whatever color that I want here. Let me use gray. Then the title that I want. Let me use format the string here. And say prediction. Then exit out of my for loop. For I in range 5. Okay, I need to do I plus 1. Perfecto. All right. So on this one, I just added a new data and I'm just plotting new data and just showing the predictions that they've done based on this new data. You cannot really see with your naked eye, but it's predicting this as 3, 6, 6, 6, 5, 6. Perfect. All right. So What we did is we imported data, handwritten data from MNIST dataset, and we were able to predict it with 98% accuracy, it's like you see from the results. And now we added a new data set, and from the new data set, we went up ahead and visualized, and it's also predicting the data as expected. So, in a nutshell, that's your neural network, feed-forward neural network. And as for a bonus, I want you to go ahead and try to do polynomial regression, or just pick any other supervised learning model that you might think of, and work on it, and also find a data set that you want to do and just work on it and see that you can apply this on your own. Thank you for watching, and bye for now.